All right, let's cut to the chase. You're here for a rapid-fire study guide on VLM checkpoints, and that's exactly what we're going to do. Look, if you're training vision language models, you know saving them is a huge deal, and it can get real messy real fast. So let's get you prepped.
And just to be clear, the stakes are incredibly high. If you get this stuff wrong, you're not just looking at a slow training run. We're talking about catastrophic system crashes, your storage costs spiraling out of control, and your whole project hitting a brick wall. This isn't just about being neat, it's about survival.
So that's the million-dollar question, right? How do we wrangle these absolute digital giants without them completely blowing up our memory and our budget? Well, the answer lies in a handful of really smart, really targeted strategies.
Okay, let's dive in. For your exam and for your real-world projects, you just need to master these 5 core strategies. We're going to break them down one by one, focusing on exactly what you need to know. No fluff.
First up, modular checkpointing. Now, the core idea here is actually super intuitive when you think about it. You almost never train a massive VLM from total scratch, right? So why on earth would you save the entire model every single time? You just save the new parts, the bits you actually changed.
And this right here shows you this staggering difference. I mean, it's night and day. We're talking about going from saving a monster 10 gigabyte plus file every time down to just a few megabytes. The savings in storage and time, they're absolutely astronomical.
So how does this actually work? Well, there are 2 key techniques you've got to remember. First, during pre-training, you might only be tweaking the projector. That's the little bridge connecting the vision and language parts. So you save only that. Then later, during fine-tuning, you're probably using something like LoRa, and you save only those tiny adapter weights. And here's the payoff, 99%. By saving just those LoRa weights, you can slash your checkpoint size by up to 99%. That isn't just an improvement, that's a whole different ballgame.
All right, let's roll into our second strategy, saving in parallel. This one is all about solving the huge traffic jam that happens when you're training a model across, dozens or even hundreds of GPUs.
The old way was, frankly, a disaster. All the different pieces of the model from all the GPUs had to get funneled into one main machine to be saved as one giant file. It was a massive bottleneck. The smart, optimized way is to just let each GPU save its own little piece, its shard, of the model directly to storage all at the same time. Now for the exam, you're going to want to know the names, DeepSpeed ZRO and PyTorch's FSDP. These are the magic frameworks that make this possible. They're smart enough to break up everything, not just the model weights, but also the gradients and the optimizer states across all the different GPUs.
And here's the bottom line on this one. By skipping that central gathering step, you totally eliminate those terrifying RAM spikes on your main machine. And, of course, the whole process of saving and loading just gets ridiculously fast.
Okay, on to strategy number 3. This one's about a simple but powerful idea. Stop wasting time. I mean, your GPUs are incredibly expensive, right? They should never, ever be sitting around doing nothing.
And here's the perfect before and after shot. In the naive setup, when it's time to save a checkpoint, the GPUs literally just stop. They sit there and wait for the file to write to the disk. You're just burning money. The optimized way, the GPUs get straight back to work on the next training step.
We pull this off with something called asynchronous checkpointing. It's a clever trick. You just make a really quick copy of the model weights over to the regular CPU memory. Then, a separate background process handles the slow-as-molasses job of writing to the disk, while your precious GPUs are already hard at work on the next step. It's all about maximizing your hardware.
For strategy 4, we're going to get down into the nitty-gritty. It turns out the actual format of the file you're saving, yeah, that can be a huge lever for optimization.
And this first trick is so simple, but the impact is massive. Just by saving your checkpoints using lower precision numbers, think BF16 or FP16 instead of the old standard FP32, you instantly cut the file size in half. That is a 50% storage saving with one easy change. It's practically a freebie.
But it's not just about size, it is absolutely about speed. Those old .pt or .bin files used a format called pickle, which is kind of slow and insecure. The new hotness is safe tensors. The key term you need to remember here is zero-copy loading. It basically means the data can be loaded directly into GPU memory without any slow, clunky processing steps in between. All right, our final strategy? Let's talk about good old-fashioned housekeeping. A really long training run can spit out dozens of checkpoints, and before you know it, your storage is full and it's a complete mess to manage.
The two core ideas here are pruning and consolidation. Pruning just means you set up a simple rule to automatically keep, say, only the top 5 best checkpoints, and you just delete the rest as you go. Consolidation is what you do at the very end. Once training's all done, you merge all those little sharded pieces or LoRa adapters back into the main model.
And the goal here is pretty simple. First, during training, you stop your storage from exploding. And second, at the end of it all, you produce one single, clean, optimized file that's ready to be put to work in a real-world application.
Okay, you made it. Let's bring it all home. This next slide. This is your ultimate cheat sheet. This is everything we've talked about all in one place.
Now this is the slide to screenshot to memorize whatever you got to do. It connects everything perfectly. For each of the 5 strategies, you've got the core mechanic and the single biggest benefit it brings to the table. From that insane 99% size reduction with modular saving, all the way to zero-copy loading with the right format, this is what you need to know.
And I'll just leave you with this one to chew on. We've just covered the 5 best ways to optimize checkpoints right now. But models are just getting bigger and bigger, growing into the trillions of parameters. So what do you think the next major bottleneck is going to be? That's a question the entire field is racing to answer.